go to the natural capital accounting, I'll also show the spatial decision support system, what we developed. Okay, this is our web page. It has the details of all the decision support system, what we have developed. And here there is the environmental information system. So now where initially we started our journey with the flora and fauna database for the Western Ghat. That is at this network is slow or it is. So you have the biodiversity, this one, then okay, it gives the various information about flora, then the fauna, okay, then also the literature, all those things. This is what we initially started this. When you take flora, you can choose this one, all the details regarding the flora provided there. This is the initial stage of the work. Then we move to the next level, okay. So where we develop the decision support system. Essentially the objective here is to identify ecologically sensitive regions in the Western Ghat at the decentralized level. So what we have done is we divided entire Western Ghat into 5 minutes by 5 minutes grid or 9 kilometer by 9 kilometer. And we compiled all the information related to the, the biogeo, the climatic, social variable, all these variables were compiled for each grid, okay? And then we integrated that information, we assigned the weight. Based on the weight, we had 4 groups in the grids. Then that 4 groups, ESR1, ESR2, ESR3, like that. Now, if you want to know which one is in your district, if you want to know which, let me go to the Karnataka or Kerala, whichever, or I will take you to Kerala because there is in the news. Yeah, see now you can see that these are the villages. The red are the ESR1, then green are ESR2, dark green, light green is ESR3, and blue is ESR4. Now you know that entire Kerala, where is the ecologically sensitive regions are in the Kerala. It's not responding. Okay. You have another mouse? See now if you want a particular district, Wayanad is in the news. Okay. I have chosen the Wayanad. Now you can see that ESR1, ESR2, ESR3. Then if you want taluk, you can go to the taluk. So whichever taluk you want, you can choose that. Okay. And then choose the village also. So okay, then associated that information. If you want to know why it is ecologically sensitive region 2 or 3 or 1, you can click on that. You will get all the associated data. Okay, associated information. So now for any village in the Western Ghat, this information is available. See, this is ESR1. So when you click on that, you get all the details. Okay. This is how the decision support system is. This one. Now you might ask, what is the use of this? There was a news, Supreme Court has, our NGT asked the Karnataka government to accept the Kasarangan committee report and all those things. There was some hesitation. when we put these details, which is a kind of a combination of Madhav Gadgil and Kastarangan committee report, only thing is we have gone down to the village level. And in Kastarangan committee report, some of the villages were deliberately left out. Not shown as ecologically sensitive because there is some hydroelectric project or something like that. So all those anomalies, we removed it. And after that, when I launched this on 14th of July, in a remote village in Karnataka, within about 10 days, the committee from the ministry visited my lab. And when I explained this, one of the things I explained is the carbon services, ecosystem services. Then the committee met the Karnataka government next day. They informed the Karnataka government the worth of the forest in terms of carbon and also the likely carbon credit Karnataka is going to get because of that. The moment it was told, then the minister said, I will accept the report. Okay. So that's where this helps in the conservation as well as the advocacy. Okay. Now with that, I will move to my presentation. So now coming to the natural capital accounting and the valuation ecosystem services, we worked on the forest ecosystem, then the agriculture and the aquatic ecosystem. But this presentation essentially about the forest ecosystem. We worked on it's almost 1.5 years we have taken to develop this for the Karnataka since the data was available. Okay. And what we did is it has a 4 component as per the SIA protocol. SIA is nothing but system of experimental ecosystem accounting. It has the ecosystem extent, ecosystem condition, then ecosystem goods and services, and then ecosystem monetary asset. And the another component is a visualizing. That means what is the likely scenario if the current situation continues and how much that has the impact on the ecosystem services. Okay. So now if you take up ecosystem extent, so initially we worked on the 10 districts, which we chose based on the agroclimatic zone. Then subsequently we moved to the entire Karnataka because we had collected a training data from the 10 district. Extrapolating for the remote sensing analysis was not a difficult thing. So that's what we did. So now if you see, this is the kind of data available, varied spatial resolution, because you people are also talking about artificial intelligence and machine learning, etc. So to analyze this big data, to understand the pattern, this AI and ML will help. So now if you look at the data, it's only the number. So you need to understand the pattern from those numbers. That's what we do when we analyze the remote sensing data. And when you look at the artificial intelligence and machine learning, the algorithm what we have been using since decades is now packaged as the machine learning algorithm. For example, we use the supervised unsupervised classifier. Earlier we used to call K means cluster. That is a part of this. And supervised cluster, we used to have the parametric and non-parametric the classifier. Parametric is the maximum likelihood classifier, while the non-parametric is the random forest. If you look at my first student worked on the random forest. At that time, I didn't coin the term machine learning, etc. It was about 15 years back. But that has helped him. Okay, now today he is a triple IT professor. So now using that, then we also can visualize what is the likely scenario. There are already proven algorithms are available, CA, Markov. You can have based on the neighborhood and also taking into account the Markov, the historical changes. You can also say that what is the likely scenario. That is what we have done for the predicting. Okay. Now, see, initially we started with a district. This district is Uttarakhand district, similar to Uttarakhand. Okay, it has a distinction of having highest forest cover in the country. 80% of the landscape is covered with the forest. See, essentially, when we take the district, we divide the district into grids. That's what is done here. So, and then we collect the data from the field. The transect based quadrant, we put the 20 meter by 20 meter quadrant for the trees, then 5 meter by 5 meter for the shrubs and 1 meter by 1 meter for the herbs. And then we use the species area curve for this one. That is about the biodiversity of the region. That is where since this district, we have covered almost 15 to 20% of the area for the detailed biodiversity mapping. And we use the vegetation map developed by the French Institute in 1985 as the ground data for classifying the remote sensing data of 85. And the current data, we use our fieldwork data. So that's how we analyze what is the spatial extent of the various land uses. So this gives across the transition, in each of the land, this one, how it has changed from time T1 to T2. So even in this district, supposed to be highest forest cover, supposed to be conserved, we see there is a large scale changes in the land use. For example, evergreen forest, which was about 62% in 70s, today it's about 29%. So that is what this one. And now if you look at agroclimatic zone or agroecological zone, the different colors indicate the zones. And then the dots indicate the district which we chose in those zones, the representative district for our the biodiversity mapping as well as the ecosystem accounting. Okay. Then with that, we collected the training data for the entire Karnataka in the second phase. First phase is about 6 months, this one. Second phase is the next 4 months. We collected training data and we used the remote sensing data and classified the changes that is happening in the landscape from 1985 to 2019. Okay. Now, compared to this, Uttarakhand, the spatial extent is very small. So if I have taken 1.5 years for this, probably the 4 to 5 months, you should be able to do that. And second thing is the Sikkim you are talking about. I was involved in the ministry's Department of Science and Technology, the biodiversity database creation and all. About 10 years back, we were talking about it. What should be the structure of the database, etc. And Sikkim was Science and Technology was an active partner. In fact, they compiled some of the information related to the biodiversity in the Sikkim. Probably you should contact. Similarly, so is the case in Uttarakhand. I remember Professor Rawat was involved in this from Kumaon University. So he was actually involved in the DST project. Probably he'll also have the database. Okay. So now this gives the extent of the spatial extent of the ecosystem. Then the next is the condition. As we were talking in the morning, there are the various, this one, we have the, the structural biotic thing where we looked at AGP, above ground biomass, below ground biomass, then carbon and soil carbon. Then the biotic, the species-based criteria, the endemic and endangered thing. What we did is, apart from our field data, we also did the data mining, compiled the information from the literature about the endemic, etc. Then the functional aspect of the biotic ecosystem is the NPP. Okay. Then we also did the fragmentation of the forest and the land surface temperature. This, for the first time for the globe, we said you have to include these two to understand the condition of the farm. And since the government of India had done the
invasive species was not included in this.
No.
Okay.
So the government of India had the soil health data at a block level. It helped us in the assessing the soil also in this exercise. Now, see, when you talk about typology, these are this one abiotic ecosystem. You have the physical state and chemical state characteristics, wherein you look at the soil structure, water availability, etc. Similarly, chemical state, you look at the nutrient level, water quality, etc. Then biotic, this one, as I said earlier, we have the structural, composition, and functional state. Functional state is NPP. Then at landscape level, we looked at the fragmentation and the land surface temperature. These two are based on the remote sensing data, because thermal band data is available. You can do the temperature assessment. So there is a direct correlation with the ecosystem degradation and LST also. Okay. Now this gives you the fragmentation of the forest. You can find out where all the intact forest is there, where patch forest is there, perforated forest, and the edge forests are there. Your species also, if you do the mapping of invasive species, naturally they are in the degraded patches, the edges, etc. So that is the reason. In our study also, we noticed that the species like lantana, eupatorium, all those things were in the edges, and the reason intact forest, we didn't see any of the invasive species. Okay. And this gives the land surface temperature, how it has changed with the changes in the land cover or the land use. Okay. So now, see, this gives the AGP, above ground biomass, and the other one, of course, we looked at the below ground biomass also. This gives the total the biomass, and the 47% of that is the carbon. Then this gives the distribution of the flora and fauna, the endemic species. Okay. So what we did is both our primary data plus the published literature, etc. We did that. Okay. Then the soil related information, since it was available, we could pull the data at the grid level, and we have for each grid the various Then we assign the weight based on the CR criteria. high, medium, low. So that the change, the transition from high to medium or low, that shows a degradation in the quality. That is what we did for the two time period, 2005 and 2020. See, that's what we have done. This is the parameters we have used. This gives the ecosystem condition, the biotic and the structural aspect and functional aspect and landscape level. And then finally, we have a consolidated thing. That's how we met the second objective. Probably this is also for the first time done in the country by IISC. Okay. Then we move to the next part, which you are looking for is the ecosystem services, the forest ecosystem and the agriculture. See, what we did is the tangible benefit, what we call it as a provisioning services, like timber, fuelwood, fish, etc. You can find out what is the quantity that has been they transacted from the respective forest. How do you get it? One is from the primary data, you can carry out the field study. Second is if some studies have been done by the students, you can compile the data. Third thing is the forest department itself has some data, especially the timber, and they also have the senior age value, which is the difference of the market price minus the cost. Once you have the quantity of the resource, the multiplied by the market price minus cost gives the benefit. See, you are taking only the benefit what you get. Suppose if you are selling 1 kg of fuel wood, you are selling at 5 rupees. If the market price is 5 rupees and the cost of extraction is 3 rupees, then 2 rupees is your profit or the benefit. That has been, that is what has been accounted in this one. So now you get for each of these, Okay. Okay, now each of the resources, we have done the quantification like that. Then we have regulating services where it is the global local climate, soil fertility, water regulation, pollination, air. There are some more also there. But what we could do it, we just considered that. Okay, we were not very ambitious. And cultural, we could do it because we were working in that region for a long time. We knew the sacred groves, the aesthetic value and spiritual and tourism, etc. So we pulled those data. Then the combination of all these three, the provisioning, regulating and cultural services is the total ecosystem supply, which is also called the gross ecosystem product. I think you called it environment product. Huh? It's an ecosystem product or a green GDP. That is what is the terminology used at international level. Now, how do you do the quantification? You can, the method is talked about it, that publication is coming out. So, you have the service wise, the goods, the timber, bamboo, etc. Find out the quantity and find out the market price and what is the cost. That is how the thing. In our case, since the data was available from the forest department, from the literature, we could do that. Then fuelwood, the data is not available in forest department. Since my publications were there on the fuelwood consumption in Karnataka, we could use that. Similarly, fish, we got the data, the fish, what has been extracted inland as well as this one. We have accounted that because in Karnataka, inland fishery, most of the streams and rivers are within the forest. We have accounted that. Then similarly, water supply, we did the quantification of the water yield in the catchment. Then what percentage has been used for the irrigation and for the domestic purpose, we accounted that. Based on that, we did the quantification. Okay. Then medicine. So we had the local interviews. Based on that, we had publication. It helped us in the one and the Karnataka Biodiversity Board. And we also have the Medicine Plant Conservation Authority. So where this data is available. Of course, all the input has gone from the organization like FRLST, etc. Then we also looked at the genetic material service also, because most of this resource also acts as a gene pool. That's where we have accounted that for this. Okay. So then this is about the agriculture, which is rather easy. In Karnataka and many states, we have something called publication called district at a glance. It gives the spatial extent as well as the kind of the crop grown and this one. And also, since there is a MSP, the minimum support price and all those things are available, we could quantify what is the benefit we get when you have the agriculture crop. Okay. So then this gives the fodder and the wood because of the agriculture activity. And then what the method we adopted is for all the tangible resources, we use the residual value method. What is residual value? You looked at what is the kind of the market price minus that is the residual value or the benefit you got. That is known as the residual value method or the rental value method. Okay, the other way is the resource rent. Suppose you give the agricultural land for the rent, you get certain things. That is the benefit you are getting. You can assign that, but that is a crude way of doing it. Instead of that, if you do the crop and then the value of the crop and quantity of the crop, then that would be better. Okay, that's what we did. And then the timber, we collected the data from the forest department and we used the residual value method for that. And in the case of timber, it was rather easy because the forest department had the stipulated senior age value. You know, for a timber quantity, what is this one per which senior age value is the market price minus the extraction cost. Okay, so that is what we have done, and then the value of the rosewood, etc., we could quantify based on that. Okay, the once we have got the per hectare value, we extrapolated for the entire region. Okay, so it's the case of bamboo, non-timber, fuelwood, etc. Okay. Then the agriculture, as I said earlier, you have the data from the government record and also some public interviews we did because for the yield, there was a government record was giving a misleading number. That is where we collected the data from some of the villages and then we extrapolated that. And from that we could compute provisioning, regulating and cultural services. Okay. So this gives the details of the method that is adopted. Okay. And then once you know that total ecosystem supply value, TESV per year, you can also find out the asset of the asset value also, that is called NPV, net present value. Say, for example, if you keep 1,000 rupees in a bank, at a 10% on average, you get 1,000 rupees every year. Now to get 1,000 rupees, what is the principal amount you have to keep it? That is called the principal NPV. So similarly, you know that every year you are getting a X amount as the service by the forest, then you assign what is the worth of the forest. Okay. So that is what, this is a standard, this one. You use the discount rate, the social discount rate for the renewable is 4%, while the non-renewable is 2%. Supreme Court said that you use 3%. We have used the 3%, not to me, but in their verdict, they have said that. Okay. So because when you develop this kind of thing, you need to have the standard protocol. So then the people accept it. Okay. If you come up with a new theory, then people will not accept. Only I will get a publication. Okay. So then see, now you look at the power of GIS, the spatial extent. Now it gives what are the goods. This gives the rosewood from the recent two time period 2005 and 2019. Then the teak wood, quantity of teak wood, eucalyptus, softwood, and all this data we got from the forest department. Then also the thing, then we started quantifying the value of that, provisioning, regulating, cultural. Okay. So now the provisioning services, when you take, it amounts to the kind of the. Now when you look at the total ecosystem supply value, see, it is surprising. See, what I did is I found out 2005, what is the total ecosystem supply value, converted that to 2019 price because I wanted to compare that with the 2019. So then you need to have the uniformity. So now at 2019 price, the worth of the ecosystem is 2,894 billion rupees per year, while in the 2019, it is 1,835 billion rupees. Now this is directly proportional to the degradation of the forest. Okay. So now this gives the agriculture. We collected the data for the crops as well as the horticulture. Agriculture means cropland plus the horticulture. As per the agriculture department, the nomenclature, we use the same result. Then this gives the district wise the resources that what we get. And also we compare that with the GDP of the district because every district has a GDP. So we said that, okay, if you are getting this much revenue from the forest from the agriculture, what is the share in the GDP? We wanted to see that and we compared that. That gives per district the ratio. Okay. Now you can see that this is a total ecosystem supply value and this gives the provisioning, regulating and cultural services of each of this one per district. The various colors are given. Once you have GIS, you can do all these things. So that's what we have done. So, okay, then this gives the TSV for this terrestrial ecosystem and NPV of the ecosystem. So now this gives the district-wise. Since we have done the district-wise analysis, you will also know that how the two time period, how the TASV has changed, okay? The temporal changes, that will give an idea whether the management is appropriate or not, okay? And this gives the changes, okay? Then we have computed GDP. For example, see in Uttarakhand district, if you look at the revenue, what is reflected in GDP is 180 crore. In the GDP of the district is 5,800 crores per year. When I did the quantification of timber, fuelwood, etc., it amounts to 9,000 to 15,000 crore. See, where is 9,000 and 15,000 crore versus the 180 crore? When I talked to the district officials, they said that 180 crore they have accounted is only for the fuelwood. They have not even accounted timber, etc. Now, this undervaluation is also costing the district. See, whatever the revenue that comes from, 10% of it is given back to the district for the developmental activity. Now, 180 crore, 10% versus 9,000 to 15,000 crore, this one you can see that. Okay, that is what we did it, and we also showed what is the kind of the share of this one. See, in the region, which are the Western Ghat district, you see the forest, the ratio of TSP to the GDP is 209. Compared to that means there is a large scale undervaluation is happening. Okay, that is what it gives out, and this gives the TSV to the GDP ratio. Okay, then to summarize what I said so far, now the total ecosystem supply value for the forest is about 2,841 billion rupees per year. Here I have written it in million. 2,841 billion rupees, which comes down to 1,835 billion rupees per year in 2019. You know, this is directly proportional to the degradation that has happened in the forest ecosystem. In fact, in one of my article, I said, we have lost this much asset and this much revenue per year from the forest. Please collect all this from the forest officials who have worked in these districts over the period of time. So because of the mismanagement only, we lost it. So, okay, then per hectare value also we computed forest, agriculture, etc. So in case if you do not have time, then you can just use the per hectare value, and that is called benefit transfer. If it is in the same ecosystem, you can adapt that value from one study to the other. That's what people do, and that's why we computed a per hectare value also. So now it gives about, you know, the forest, this one is about look at the per hectare value. You can say that 6 lakh rupees per hectare per year is the kind of the service that provides. It goes up to 10 lakh rupees per hectare per year. Okay. And based on that, we have computed NPV. The NPV of the forest ecosystem is 73,000 is the asset value of the forest billion rupees, 73,000 billion rupees in 2005 at 2019 price. Now, 2019, it is 47,000 billion rupees is the asset value. This is mainly because we lost the productivity, because we lost the quality of product. That is where we lost it. That's where the degradation has happened. And naturally, you see there is an increase in the agriculture. The people converted forest land into agriculture. There is an increase. 20,000 billion rupees has gone up to 27,000 billion rupees agriculture. Okay. So that is what we have computed, that NPV as well as the TSV. Okay, now I'll stop here. And these are some of the studies which I had done earlier. You know, if the lake is not polluted, the worth of the lake is people get the goods worth 10,500 rupees per day per hectare, which include the fish, food, water, etc. Whereas if it is polluted, 20 rupees per day per hectare. Okay, that is that shows how the ecosystem, when we neglect, how the disservice happens. In fact, in this water body, we also notice every family spends 30,000 rupees per year on the medicine and repellent because of the poor quality of the water in the neighborhood. See, that is where this ecosystem service will help in driving the message louder, and the people also understand that. Okay, so, and these are the various studies people have done, and some of the studies are from my group. Okay, and this is the wetlands in the Karnataka. We have about 39,000 wetlands, where Karnataka government said there are no wetlands in Karnataka when I was in the first meeting of the Karnataka Wetland Authority. But within a year, I have changed the mindset. Not only I got the one wetland at the Ramsar site, in addition to that, today they say 14,000 wetlands are there in Karnataka. You know what I did is there is a Supreme Court judgment was there, saying that any water body greater than 2.5 hectare is the wetland. So I asked the ministry, MOF, to send that communication to all the state, ask for the details of the water body greater than 2.5 hectare. So when they communicated to the ministry, we said that that is the wetland. Since I am in the National Wetland Committee, I could drive the message home, okay? So now then we did the provisioning, regulating and cultural services. Regulating services of the wetland includes the groundwater recharge, shoreline stabilization, the carbon sequestration, etc. And cultural services, you all know that how we use the river, this one. So now we have the wetland. If you look at the kind of the provisioning services what we get, and total it works out to be 284 billion rupees per year for the entire Karnataka. And if you look at the asset value, it's about 7,320 billion rupees. Okay, so then per hectare value also I computed for all these wetlands, so that if someone wants to adopt this value and say quantify what is the worth of the wetland, if they are unable to do the detailed study, then they should be able to do it with this kind of the assessment. Then we did the scenario based assessment. We projected what is the likely scenario of this one. That component is missing in your project. You should find out what is this one. You can look at various scenarios. We have looked at the business as usual scenario. That means whatever the land use change is happening, if it continues to happen, what is this one? Then agent based scenario. That means there are a lot of agents like building roads, etc. is happening. Then what is the change? Then if you do the protection of the thing, then what is then the afforestation, if it is done, what is the likely scenario, the change, and sustainable development, which is nothing but integration of all these first three. Okay. So we have used the standard protocol. I'll not get into the detail. We use the constraints as well as the agents of change. Okay. Then we visualize this one. See, these are all the various scenarios you can visualize. See, all the taluk, the headquarters will get more urbanized in Karnataka. That's what it shows. And this is the sustainable development scenario, where if you do the protection and afforestation along with the development, that is what we call sustainable development. We say that is the scenario we should adopt. And we also did a comparative assessment. We found that among these STP scenarios, the more appropriate. Okay. So now this gives you this one. You can see that STP is the beneficial or the ecosystem friendly scenario. Okay. So that we had a various things. Now similar to what we have here, stakeholder meetings, we met even the government officials. I had a brainstorming session with this one, and also people, technical experts also, panel discussion. Then of course there was a webinar also. And then after doing the job, we got Negi and Dr. Pandey also. They were also in this one when I did the presentation. This is what we finally gave it to the government of Karnataka. So at that time, every mouth was closed. So the convincing them was not that difficult. Okay. So that is what is the project is. Okay.